we have Vishal joining us. He'll be talking about data fetching done right. He's a front-end engineer at Tata One NG.
Hi everyone, so thanks for joining in. Today I'm going to talk about how we improved data fetching in our 1mg application and improve the performance of our application, specifically the perceived performance of a user. Uh, so before proceeding further, let me set a context about this talk. So last year I gave a talk about how we implemented predictive prefetching in our application, and that was implemented for basically improve the overall performance of application where we can basically navigate to next page faster. And in that talk, I gave some pointers like what we are planning next. So in that, the third point that I mentioned was start fetching data when we have a likelihood score of more than 90%. Like if we have a probability of a user to basically navigate to next page, it's a more than 90%, we are going to fetch data and assets for that page also. So this talk is going to be around this, like what all hurdles we faced like during this implementation and how we implemented it. So like before starting on implementation, I want to talk about what basically what type of data fetchings we have in not React, in most of the web application. So in any dynamic application, there's going to be initial data fetching, like when you open a page on an application, you need a certain dynamic data to render that page and make it interaction ready. That is going to be initial data fetching. And another one is data on demand, like when user interact with your page, maybe clicking on a CTA, which loads some additional data. So in this talk, we are going to talk about initial data fetching only. We are not going to focus on data on demand. So initial data fetching, also there are three types of implementations that we can do. So the first one is fetch before render, as you can see. So in this, what we do is we make an API call first, and then we get the data, and then we get that data, like data is ready for consumption. We will start rendering our React application and then pass that data to application using a context API, or maybe you are using Redux or any third-party state management library, or if we go basic, we can set that in window also. And then while React will render, then it will consume that data and it will not show any kind of loaders or anything because the data is available to us. So it will render the page completely. So this type of approach is mostly used in server-side renderings, because in server-side rendering, we cannot re-render our application. It's going to be one render only, like it is going to render the application and give you the HTML. So in those cases, we generally want to have data readily available with us so that we can render the whole page with dynamic data. And other type of rendering is render then fetch. So what happens in this React application, basically we will start rendering out the application, and then while your components are rendering, you may have a use effect or any other data fetching library. If you are using, you will be defining that in your component, and uh, basically you'll make an API call there, and it'll show some fallback UI on the page. Meanwhile, like when you are fetching that data, and uh, after you get that data, if you have a highly dynamic application, maybe based on that data, you are determining like what next you are going to render. So this makes a chain basically. Your previous data is determining what React component you are going to render next, and then in React, in that component, you may be fetching some other data for that particular component or a section of your page. And the last one is render as you fetch. So what happens in this, when we start rendering, we start fetching data parallelly. So it's kind of decoupled from your rendering cycle. It's going to be like you maybe have some connection between your component and fetching. Like you may have a data fetching at the top of your application, where you are making the API call and also fetch assets for that page, like CSS and JavaScript chunks. And depending on whether you fetch your data first or you get your assets first, either you will going to show the loaders, or you are going to show the completely rendered page, like with data to the user. Um, so, like before going further down in data fetching, first I want to clarify like why is this required? So to understand this, first we need to understand like what is a performant application, like how we can know. So the very basic criteria to measure the performance of any application is we need to just measure the time it takes for that application to become interaction ready. So like how fast user can interact with this. So this does not consider loaders, because if you are showing loader to the user, it's not interaction ready. So you need the data, the dynamic, the API or dynamic data, or the assets to make that app ready for the user. And when we talk about big applications like 1mg, there are going to be certain um, approach or techniques that we are going to use to make this number as small as we can. So first one is page level chunking. We are going to chunk our application into very small JavaScript bundles, because we don't want to download any JavaScript, CSS, or any other assets which is not required for that page or that part of the page. So we are going to download as minimum JavaScript as we can. And then other part is we are also going to download data. Like we are going to make API calls only for that page. Like if you are not going to download any other data which is not required on that page to um, like consume basically less bandwidth, we can say, or keeping this network call at minimum. But there is okay. Let's just understand how this navigation process in a chunked application look like. So here's this. So this is a 1mg homepage that I'm showing here. So when you load this page, so this is recorded. Like I took these screenshots in slow 3G, because in 4G or 5G it's going to happen very fast. But if you check it in slow 3G, it's going to first show you the fallback skeleton UI. So this skeleton UI means you are downloading your JavaScript and CSS. You haven't got those assets yet. And then as soon as you get the assets, the fallback is going to change a bit according to what type of widgets we are going to show on that page. So this second skeleton means we have got our assets. Now we are making API calls to get the dynamic data. And at last, when we get the data, we show a fully rendered page to our users. So like at this point, our page is finally ready for the interaction. But there's one problem with this approach. So this makes it like there's a waterfall effect in this, because first you are going to download the chunks, the lazy load the code. Then you are going to make the API calls to basically download the data for that page. So if we see this in effect, it's going to look something like this. So in this, if we see the network graph of this video, it looks like this. We are first downloading the assets, the JavaScript and CSS, and then we make this API call to get the products. Um, So like this is very basic application. So we can see the assets are downloading very fast, but depending on complexity of your page, if you have very huge page and you are using much like more JavaScript and CSS, your JS and CSS bundle might take some time to load, and then you'll make API call to get the dynamic data. So it's going to be basically uh, we cannot say slow, but it's going to take time because everything is happening in series now. So the solution for this is we need to move the code which is responsible to fetch the data out of the code which is going to lazy load. So ultimately, like what we need to do is if our data fetching logic resides between in the code, the chunk code for that page, we need to move it out. But the implementation wise, the issue is like where we are going to place it. So the implementation that we did is we moved out that data fetching logic out of use effects. Like we were using Redux thunk to handle the async operations and using use effects to dispatch those actions. What we did is we moved out that data fetching logic from use effect to a separate function. And then we basically, based on like, as soon as you navigate on to the particular page, we execute both like a chunk prefetching. Our application is going to do it automatically. But as soon as the page change, we make API call to load the data also. And if we see the demo, it's going to look something like this. So in this, if you see the network graph now, our asset call and our data call, like this products get API call, it's going in parallel. So I want to show the code also. So this is a very basic application that I have built on our in-house framework, which is Catalyst. So like Saurav is going to talk about this in person. So in this application, basically I have 4 routes and one homepage route. So if I go to implementation, so what we did is like this is our page which is responsible for rendering the UI. So what we did, we created a client fetcher function. So this is the function which is going to fetch the data for this page. So if you see in it, it's a simple function where we are making an API call to fetch the data, and then we are returning that data. And then we created a hook. Yeah. So we created a hook which is going to return you all these uh, variables. So we have one more variable. You can also get the error here. So it's going to basically change whenever your like data in sorry, whenever this promise resolve, this you're going to get the data. Whenever this client fetcher function is executed, you are going to get this is fetching as true based on if API succeeds or it fails. You're going to either get the data or error. So this is basic abstraction over you can say a basic implementation of any uh, dynamic data handling. Generally, we do it like this, and you can consume it in your application. So like what I did is if my is fetching is true, I'm going to show a skeleton, and if I have data, I'm going to render out that data. So how it differs from a current or the existing implementation that we had. So existing was like this. We had a use effect, and this use effect was basically fetching the data. So if I go to my routes.js, so if you see this explore and explore gun, like all the routes are loading lazily. So these are all going to be chunks. But then you can say that still this client fetcher is part of explore function, explore component, which is again going to be lazy load. So we created a handy Babel plugin for this. So what that plugin does it during the build time, it search for all the client fetchers in your page directory and move that into a separate bundle. So if I show you, it's going to look like something like this. So I have this build folder. If you see in build folder, I have these client fetcher functions defined on my pages. So what it is doing basically, it is searching for client fetcher property on present in your uh, containers which you have passed to the route array, and then it is extracting out that client fetcher and moving it here. That's why we have mentioned one more thing, that this should be a pure function. You shouldn't be doing any mutations in it, because then on the during runtime you might have certain if side effects, which maybe some errors, because it will not be able to change things outside its scope. So if I come back here, okay, so this is the implementation where we have moved out data fetching basically outside um, our like code which is going to lazy load, but our ultimate goal was to integrate it with asset prefetching, right? So third point, if you remember, was to prefetch the assets, sorry, data along with assets. But the issue that we faced was, like, prefetching assets is not that costly, but if you start prefetching data, it's going to um, take more bandwidth in your server, like, because we will be doing DB operations and all in backend. And if we start making um, fetch calls, or like data fetch calls which we are not using, and we make extra fetch call, this might uh, affect our application. So what we did is we implemented data fetching and sorry, data prefetching and asset prefetching both, but we gave this control to the user. Um, so what I meant with that is, if I go to there, so if you see here, we have this same component, same client fetcher a function written here also. This is also making an API call and fetching the data. But the difference in this is, if I go to home, then I have two hooks mentioned here. Use prefetch route. So this hook is basically responsible for prefetching assets against this route. And then I have one more hook defined here, use fetch route data. So what this hook is going to do is, it is going to fetch the API. So like, this hook is going to execute the client fetcher function defined against this route. So basically, if I go to my route.js, so against this, I have this component. So ultimately, it is going to run this client fetcher function. But there is one thing that we have defined here. We are passing this is prefetched flag here, because um, you don't want to degrade the performance of your current page due to, like, prefetching or data for the next page, right? So we did what we did. We are passing this flag here, using which you can set the priority of this fetch call as like low, or if the prefetched is false, it's on next page only, then you can set it to auto. So if we see how it is looking, it's going to look like something like this. So if you see, this is like instant, because we are fetching both data and asset earlier. So you will be having everything readily available, and um, like, you can see the result in instant on navigation. So I've created this comparison video. I've recorded all three here. So if I play out this, it's going to look like this. So first one is where you have API call defined in use effect. Second one is with client fetcher, and third one is where you are prefetching assets and data both on the previous page. This is on slow 3G. That's why I was able to, like, record this. Okay. So this is all about where you are fetching the data in can say client side, where you are navigating from one page to another page and client side navigation is happening. Then you are okay fetching the assets, fetching the data, and rendering out your application. But what happens when if you want to implement the server side rendering in your application and want to uh, render your page on the server? So we have created, so if I go to the code again, so I've created a similar function to the client fetcher, which we are calling as like server fetcher. So if you see, the code is almost same in client fetcher and server fetcher. We are making the API call, getting the data and returning it. The only difference is in server fetcher function, you are going to have access to your request response, route, your params, um, all these variables. And in client fetcher, you can access the window variable because server fetcher is going to be executed on server side. So if you're using Express on your server, then or any other server framework, you will be having access to request and response, like whatever you are passing from your application. Uh, you will get that access in the server fetcher function. So if we see this in action, it's going to look something like this. Let me open up network tab. And if I refresh this, you will get the data like whole page completely rendered. Um, so one thing I want to show in this is if I go to, okay. The thing is, for server side rendering is you fetch the data on server, but when your client hydration start, you don't want to refetch that data again, right? You don't want to make API call twice on server and on in client both. So we need to find out a way where we can pass down the data from server to client. So in our router, we implemented a simple variable. So what we are doing is we are basically Uh, s- so the data like which we are going to fetch against this route, we'll set that in router initial data. And in this, if you see its structure, it's going to be your route. So this route is here for to maintain the child routes of your application. Like if you have um, uh, parent-child routes and you are fetching data in multiple routes, then you will get all those keys here in this router initial data object. So the API call that I'm making in server, I'm setting that data in for against this key. And when the rendering or I can say hydration start in client side, I will get this initial data from this window variable and set it in my context, like where all the client fetches which I run, I store data in a context. I'm going to pass this initial data directly to that so that I'm not making the API call twice. And uh, if we have some private APIs which you cannot expose to the client and only run on server, you will be having that flexibility where you fetch the data on server, render out your page, and then pass down the required data and hydrate your page in the client side. Okay. Cool. So one more thing I want to mention is we have published this package on NPM, so you can try it out. It's in beta. We are still figuring out some things, but by the end or the mid of next month, we are hoping to release a stable version. But if you want to try it out, give us some feedback, you can try it out. The package name is @Tata1mg/router. It's built over React Router DOM. So we are exporting everything from React Router DOM. Plus, we have some APIs, or you can say wrappers that we have built over React Router DOM. So everything is mentioned in the documentation. You can try it out and let us know. your feedback. And that's it. Thank you, everyone.